Hello, so for problem 9 we have determine the limit describing how you arrive at each value. So for the limit of 1, we have both coming from the negative side, the left side, and coming from the positive side, the right side. Both sides meet at the same y value, which is y of 5. So for 1, the values are 5. However, although both of them are the same, the general limit does not exist because this is an undefined open point and we cannot have any undefined points on our graph. So if we move further down, we have the limit of 3 as x approaches. So we find x value of 3, come up here, and once again, coming from the left side and the right side, they still both meet at the same y value, which is 4, and that's how we got 4 here. Because these two coming from the positive and negative are the same 4, then the general limit is also 4 because both of the points are defined and both points are the same. For the limit of 5, moving from positive and negative towards it, we find x on the x value 5, but we have 2 points at it, one defined and one undefined. So right then and there, we know the general limit will not exist. Coming from the left side, we have it at the y value of 3. Coming from the right side, we have it at the y value of 2. That is how we got 3 for negative and 2 for positive. When we try to hit the limit of 8, coming from both ways, from the left side negative, we have it at the y value of 6. Similarly, coming from the right side positively, we have it at the y value of 6. And because both of them are equal to, the general limit is also 6. So that is why those are all 6. Now, for B, for which values of x is not continuous, we have x equals 1 and x equals 5, further proven by the general limit that x equals 1 and x equals 5 that does not exist. For part 3, we have for each x value where f of x is not continuous, use mathematical definition of continuity to explain why f of x is not continuous. So, here we have our definition equation. F of x is continuous at x equals a. So the limit as x approaches a, f of x equals f of a. Basically meaning that the limit as x approaches a of f of x is equal to f of a. So, when we get to why are these not continuous, x equals 1 is removal discontinuity, which is anytime the limit is real but not continuous, we call that removal discontinuity, and that is because we had a point that is undefined at x equals 1. For x equals 5, we have jump discontinuity, which is the left and right sides with different values. And that is because we had 2 different values at x equals 5 correlating to 2 different y values. And that is how we got